Pulse width modulation is so important to this hobby. I mean, it's integral to it. It's what our radios put out to tell our platforms what to do. That's changing with digital, but we'll not get into that at this second. We're going to stick to the old analog ways. And what we have here on the table is my pulse width modulation monitor and my servo tester that generates a pulse width modulated signal, and an oscilloscope so we can see this. I wanted to say a little bit about what we see here on the screen. So I'm going to first scroll in, if I can, to the bottom of this scope. So we've got a 5.09 volt signal there at a frequency of 60 hertz, putting out a 988, 990 microsecond pulse. The time duration of the overall signal, that is 5 volts, is 990 microseconds right now. I'm not going to zoom back out and refocus right now on the servo tester, but I'm rotating the dial to the right. Now there's a little bit of a problem with this because this the oscilloscope's on milliseconds right now. So when it steps over into what the pulse width monitor on the table says is 1030 microseconds, is 1.3 milliseconds on the screen. Those two numbers are the same. You move the decimal point 3 positions to the right and you get 1030 microseconds, which is what the PWM monitor says down here. Now as I crank that up, we're going to go all the way up to 1.99 microseconds, which the pulse width monitor on the table is bouncing between 1999 and 2000. The oscilloscope's a little more steady. So there's your change from 2000, 1.999 on the milliseconds, to down to 988 and 990 millisecond pulse. This happens 60 times per second. That's the frequency. So 60 times per second, the width of this pulse is sent to the receiver. No matter what the width of it is, that doesn't change. The frequency is constant. 60 times per second. The receiver sees whatever the width of the pulse is. Let's see if I can scroll back out. Oh, that's what we see on the screen. So now I'm going to show you the pulse width monitor while I change the resistor on the servo tester. And you can see as the number goes up, the falling edge of that signal moves to the right. And as the number goes down, the falling edge of that signal, or that pulse, within that signal, the signal is 1/60th of a second. Overall signal is. Part of it is 0. This part out here is 0 volts, whereas that pulse is 5 volts. So again, let me widen this out just a little. Let's see if we can, there. We're changing the time scale right to left on the oscilloscope there. And let me change that value again. We're going to go to the higher pulse width now. That's our highest. And we're going to lower the pulse width now. So 60 times a second. or this analog pulse, whatever it is, or if it's that wide or that wide or that wide, it doesn't matter. Whatever it is at that time, 60 times a second, that information is sent to the receiver. The falling edge of this pulse is proportional to the number coming in. Right there is about 1500. The pulse width monitor says 1469, but I trust the oscilloscope more than a little cheap pulse width monitor. There we go. We stepped that up. We can see now on the oscilloscope multiple signals. I changed the time that we were looking at so that the time period expands through 1, 2, 3, 4 full signals in the beginning of another, and just a little of the end of a signal there. So there's 1, 2, 3, 4 full signals. And you can see when I change these, the potentiometer on the servo tester, how that pulse width changes. The overall time period that we're looking at on the oscilloscope doesn't change. The overall 1/60th of a second slice of each pulse width, or the whole signal, doesn't change. It's just the width of the 5-volt portion. That's all that's going on here. So the width of the 0-volt portion gets less as the 5-volt portion gets higher. I hope that's not too confusing. Anyway, this basically, I hope, explains pulse width modulation to you, explains why this number equals a certain position on a servo. And you can see on the screen that it's the width of the 5-volt, the duration of the 5 volts that we're talking about. So I'm going to cut this off right here. I'm trying to redo all these videos so they're smaller slices of different topics to help people. And I don't want to water this down with the tangents and sidetracks that I frequently get off onto. Thank you so much.